Welcome back to the AI Research Roundup. I'm your host, Alex. Alright, today we're looking at SkyReels-V2, Infinite Length Film Generative Model, published April 17th, 2025. So, current AI video tools often struggle with long, high-quality videos that truly follow prompts and look like real films. This paper introduces SkyReels-V2 to tackle these issues. It combines advanced techniques like Multi-modal Large Language Models, or MLLMs. These are AIs that understand various data like text and images simultaneously, and reinforcement learning, or RL, where the AI learns through trial and error, improving its video creation. Alright, and for those of you eager to get hands-on with this, well, the SkyReels-V2 repository is up on GitHub. It's got the model weights. These are the learned settings that make the AI work. All the inference code, which is what you'd use to actually run the model and generate these infinite length films. And of course, instructions and scripts like _generate_video.py to help you get started. Okay, so figure 1 here really showcases what SkyReels-V2 can do. We're seeing several examples of video generation. Things like a cyclist on a mountain road, a race car, even a kangaroo in a sun hat, and a sea turtle. What's striking is the progression across frames, from frame 1 all the way to frame 256 and beyond, indicated by an arrow towards infinity. This demonstrates the model's ability to maintain visual consistency and quality over these extended sequences, which is a big step towards that infinite length film generation they're aiming for. Okay, so while figure 1 showed us the impressive results, figure 2 here details the method. It's a multi-stage pipeline. First, progressive resolution pre-training uses their Sky Captioner V1 for detailed video descriptions, then trains a diffusion transformer, or DIT, an AI architecture for generation at increasing resolutions. Next, post-training refines the model with supervised fine-tuning, or SFT. That's like specialized coaching, plus the reinforcement learning we mentioned, and diffusion forcing, which is vital for creating those long videos. This entire setup powers the different applications. Alright, building on that multi-stage pipeline we just saw in figure 2, figure 3 here gives us a more granular look at the data processing involved. It starts with data sources, which undergo shot segmentation. That's breaking down videos into individual shots or scenes, and captioning. After some initial filtering, like removing duplicates, this data forms a pool. From this pool, data enters the pre-training stages at increasing resolutions, 256p, then 360p, and 540p. Each stage applies more specific filters, like an optical character recognition filter, or OCR filter, which helps remove unwanted text from frames, plus motion and aesthetic filters. Finally, human-in-the-loop validation checks for issues, guiding the, quote, post-training stages for 540p and 720p video to ensure high quality. Okay, so after all that data processing and filtering we saw in figure 3, figure 5 here shows us something really important about the data itself, its balance. We're looking at 2 bars charts. The one on the left shows an unbalanced data set, where human subjects make up a whopping 84.8%. But on the right, in the balanced data set, while human is still the largest at 63.2%, you can see a much better distribution. Categories like scenery, animal, and architecture have noticeably larger percentages. This data balancing is key for making sure the AI learns to generate a wide variety of scenes, not just videos dominated by people. Okay, so after ensuring the data is balanced, which we saw in figure 5, figure 6 here shows us how the model actually understands the content of these videos. We're looking at what they call a structural caption. This isn't just a simple sentence. It's a really detailed, organized description. You can see it lists subjects, like human or vehicles, and for each one it describes their appearance, action, even expression and position in the frame. It also details cinematic elements like, quote, shot_type, camera_motion, and the overall environment and lighting. This rich, structured information is what helps the AI learn to generate videos that really match complex descriptions. Alright, so we just talked about how those rich structural captions are key for detailed video generation. Well, Table 3 here actually shows us how good their special model, SkyCaptionerV1, is at creating those structural captions compared to other approaches. This table compares model performance on what they call a visual understanding test set. And you can see SkyCaptionerV1 achieves the highest average accuracy, a solid 76.3% across various attributes. It's particularly strong in understanding cinematic details, like shot type and shot angle. This superior ability of SkyCaptionerV1 to describe video content is fundamental to SkyReels-V2's success in following complex prompts. So we've seen that SkyCaptionerV1 is really good at creating those detailed structural captions. Table 5 here now shows us how SkyReels-V2 itself, the main video generation model, stacks up against other leading text-to-video models. This evaluation is done using something called SkyReels Bench, which scores models on a 1 to 5 scale across several aspects. You can see SkyReels-V2 achieves the highest average score of 3.14. It's particularly strong in instruction adherence, meaning how well it follows the text prompt, with a score of 3.15, and also in consistency at 3.35. This really highlights how that superior captioning ability we just talked about helps SkyReels-V2 generate videos that accurately reflect complex requests. As we've seen, SkyReels-V2 really pushes the boundaries. Its ability to generate potentially infinite-length videos, and the way it follows complex instructions so accurately, largely due to those detailed structural captions, that's a major leap. This kind of progress is super exciting for AI-driven creative content generation, really opening up new avenues for storytelling. Well, that's all for this episode of the AI Research Roundup. Thanks for listening. I'm Alex.